Hi guys, I'm going to demonstrate to you all the simulation of passcode modulation by using MATLAB Simulink. So first of all, you have to open the MATLAB software. Once you open the MATLAB software, this is the default layout that will be appeared. I'm using MATLAB R 2017A version, so it might be a little bit different if you are using other version of MATLAB. So what we are going to use is this one here, the MATLAB Simulink. Okay, so you have to click this Simulink icon. So this is the blank window that will be open once you click the Simulink icon. Okay, so you can just give any name to this file. So I'm giving the file name as PCM, passcode modulation. Okay, just click file and click save, and you can choose any place you want to save this file. Okay, so this is where we can create our block, Simulink block. Okay, so first of all, you have to search inside this Simulink library browser here. So here are the list of plots that will be appeared once you click the library browser here. Okay, so you can see there are a lot of plots that you can use, depends on your simulation. So for example, you are going to produce a sine wave, so you just type the sine wave inside the search here. So it will give you a few options here, which one you want to use. So for example, I'm going to use this one here, sine wave. So just click and drag to the windows. Okay, it's very simple. For the other block, also you can just repeat the same thing. Okay, for example, in this experiment 9, we are going to use sample and hold. Sample and hold block. Okay, you just type and it will give to you a few options of sample and hold. So you have to choose this one, which has two inputs here. Just click here and drag to the windows here. Okay, I'll show to you another one. For example, quantizer. Just type here and then directly it will give to you the blocks that you want. Okay, so it's very simple. So I'll show to you the Simulink block diagram that I have created for this experiment 9. Okay, so this is the Simulink block diagram for passcode modulation that has been created. Okay, so you can see here the blocks that have been used is passcode, pass generator, sine wave, scope. Okay, we have scope 1 and scope 2 here, sample and hold plot, and also quantizer. Okay, for sine wave, this is where the signal is generated here. We want the sine signal, and this is the pulse generator, which is to generate the pulse. For scope 1, it will observe the signal from the sine and also from the pulse generator here. And we have a sample and hold scope. This is where the sampling process will occur. So sampling is the process of taking samples of the analog input signal as Nyquist sampling rates. Okay, and then after that, after the signal has been sampled, you will go to quantizer. So quantizer is the process of converting the sample values of amplitude by a finite size of discrete levels. Okay, so this is the scope 2. You will observe three signal here. So the first scope, it will observe the signal from sine wave. The second one will observe the signal from the pulse generator, and the third one will observe the signal after the quantization process. Okay, so this is where we want to evaluate and analyze our result here. Okay, so now you have to insert all the parameters inside each of the block function here. So for the first one, we go to the sine wave here to see what parameter should be inserted inside here. Okay, you can also refer to your notes, okay, to see the values. Okay, yeah, the list of the value here. Okay, just click OK. Then next one, we go to the pulse generator. Okay, And then for the scope, we have scope 1 and scope 2 here. Okay, so we have scope 1 and scope 2. So you can just make it available to be connected to two scopes for scope 1, and for scope 2 you have to make it 3 inputs. Okay, for the first one, you can just give any name. Okay, for example, this is what I have given the name here. As you can see, the first one is the input sine wave, and the second one is the sample pass. Okay, for another one scope, so we have 3 inputs here. We have input sine wave, sample pass, and quantized signal. Okay, and then another 2 blocks, which is sample and hold and quantizer. Okay, for sample and hold, you can just input the value here. Okay, 1 and 0. And then for the quantizer, okay, just give the quantization interval value, which is equal to 1. Okay, and then after that, you can start to simulate. Just press this button. Okay, this is one button. Just click this one, and then it will be started.